Hello everyone, this is Mr. Appel, and I'm going to show you how to solve this system using the substitution method. So just like two variable substitutions, it's generally best to try to find a variable with a coefficient of 1 so that we don't, when we get it by itself and prepare to substitute, we don't have to divide. So the first one I see is in this first equation. I notice that the x is all by itself. So I'm choosing x to be the variable that I'm going to get rid of through substitution. I could have also chosen this y or even this negative z here, because those also have a coefficient of 1, so I could do substitution without dividing, but I'm going to choose this first one. So the first step is to get the x by itself, so I'm going to subtract the 2y and the 5z, so it's going to become negative 2y minus 5z minus 17 is equal to x. And now I'm going to do my substitution. So I'm going to replace x with that. And I'm going to do that in both of the other two equations. I'm going to do it in both of these equations. And hopefully what you can see is going to happen is we're then going to have equations with just y and z. So we're going to have two equations with just two variables, which we already know how to solve. That's always the goal, is to break it down from 3 equations and 3 variables to 2 equations and 2 variables. So first let's do the second one. So I'm going to replace that x with the negative 2y minus 5z minus 17. This does get a little bit tedious, but it is an option. Now I'm going to distribute, so that's a negative 4y minus 10z minus 34, and then minus the 3y, the 2z, and the negative 16. And now I'm just going to clean that up a little bit, combine the y's together, so that's negative 7y, and then the z's, negative 10z plus 2z, so that's a negative 8z. And then I'm going to move that 34 over. So I'm going to add the 34 to the other side. And negative 16 plus 34, what is that, 18. So there's one of the equations that I want. Now I'm going to do the same thing with this equation. Do that over here. I'm going to run out of space. So that's going to become 3 times the x, and again the x is negative 2y minus 5z minus 17 plus the y minus the z equals the 3. And I'm going to go ahead and clean this up too, so that's distributing a negative 6y minus 15z minus 51 plus the y minus the z equals 3. And now let's clean that up. Let's combine the y's together. That's a negative 5y. There's a negative 16z. And then I'm going to add that 51 to both sides. So that's 54. So now I've got 2 equations with 2 variables, and now you should know how to solve that. So I'm just going to move this down here to make it a little easier to work with. Okay, so now we're going to solve this from here the way you would solve any system. So you should be good with that. So at this point, if you wanted to move on, you could. But if you want to keep watching, feel free. So from here, this one's going to get pretty ugly to do by substitution, because here you can see they all have coefficients, and coefficients that are going to give me a bunch of fractions. So solving this system by substitution would be terrible. So I'm going to choose elimination, and I notice that the z's, this is a 16 and an 8, so all I have to do is multiply this bottom equation by a negative 2, and I can do elimination. So that equation is going to become positive 14y plus 16z, is equal to negative 36. The top equation I'm going to rewrite. And I'm going to go ahead and add those together. So negative 5 plus 14, that's a 9y. The z's cancel, that was the whole point. And then that adds up to 18. Dividing by 9, we get that y is equal to 2. Once you've got that, the rest should be pretty straightforward. Take that, y equals 2, plug it back into any one of the previous equations. I'll just plug it in there just because it's there to solve for z. So that's negative 14 minus 8z equals 18. And then we'll add the 14 to both sides. And that's 18, 28, 32. And then divide both sides by negative 8. And we get z equals negative 4. And once you've got y and z, we can go back up to the original equation, any one of the original equations for that matter. I'm going to choose the very first one, just again because it's got a single x. So that's going to become x plus 2 times y, which is 2, plus 5 times z, which is negative 4, is equal to negative 17. And then we're going to go ahead and solve that. So that's x plus 4 minus 20 equals negative 17. And that's x minus 16 equals negative 17. And then if we add the 16 to both sides, we get x equals negative 1. And so my solution is negative 1, 2, and negative 4. That's all for now. Thanks.